Welcome to this session on C coding best practices. Here we will explore how to write code that is not only functional, but also clean, efficient, and easy to maintain. We will cover several key areas. First, code formatting and style, to ensure our code is visually consistent and easy to read. Second, naming conventions, discussing how to choose meaningful names for variables, functions, and other elements. Third, function design, including how to structure functions for clarity and reusability. Fourth, memory management, teaching how to avoid common pitfalls like memory leaks. Finally, error handling to make our code robust and reliable. By following best practices, we can improve the readability of our code, making it easier for others and our future selves to understand. It also helps in easier maintenance, reducing the time and effort required to update and fix code. Applying these techniques reduces the number of bugs, leading to more stable and reliable software. The best practices will enable better performance, optimizing resource usage and execution speed, and facilitate effective team collaboration, because consistent code style makes it easier to work together on projects. Let's delve into code formatting and style. It is essential for maintaining readability and consistency across your projects. It includes using consistent indentation, typically 4 spaces or a tab, to clearly show the structure of your code. Limiting line length to between 80 and 100 characters improves readability, especially on smaller screens. Put spaces around operators such as plus, minus, equals to make expressions more readable. Place braces on their own lines to clearly delineate code blocks. Group related code blocks together with blank lines to separate logical sections, enhancing code organization. Let's consider an example of good formatting. We have a function named calculate_area, which takes the length and width as input and calculates the area of a rectangle. Notice the consistent indentation, spaces around operators, and the placement of braces on their own lines. This makes the code easier to read and understand. Now let's discuss naming conventions. Choosing meaningful names for variables, functions, and other elements is crucial for code clarity. Variables should use snake case, which means words are separated by underscores, such as user_age. This makes variable names more readable. Constants should be in uppercase, for example, max_buffer_size. Functions also use snake case, such as calculate_area, which clearly describes the function's purpose. Structs should use Pascal case, where each word starts with a capital letter, such as user profile. Let's look at some naming examples. We define a constant, max users, in uppercase. Our struct, user profile, uses Pascal case and includes variables like first_name, last_name, and age, all using snake case. The function, display_user_info, follows the snake case convention, making the code easier to understand and maintain. Let's explore function design and organization. Well-designed functions are the backbone of maintainable and efficient code. Apply the single responsibility principle, which means each function should have one specific job. Keep functions short, ideally less than 30 lines, to make them easier to understand and manage. Limit the number of parameters to 4 or fewer, to avoid complexity. Use descriptive function names that clearly indicate what the function does. Document your code with clear comments, explaining the function's purpose, parameters, and return values. Return error codes consistently to handle issues effectively. Validate all input parameters to ensure your function handles unexpected values gracefully. Here is an example of a well-designed function. The process_user_data function validates the user ID and processes user data. It checks for invalid input and returns a status code indicating success or failure. This function is concise, well-documented, and handles errors gracefully, making it easy to understand and maintain. Now we will turn our attention to memory management and efficiency. Proper memory management is critical in C to prevent common issues and ensure efficient resource usage. Some common memory pitfalls include memory leaks, which occur when you forget to free allocated memory. Double free errors, which happen when you attempt to free the same memory twice. Null pointer dereferences, which result from trying to access memory through a null pointer. Buffer overflows, which occur when you write beyond the allocated memory, and uninitialized variables, which can lead to unexpected behavior. Here are some key takeaways. Always free what you malloc to prevent memory leaks. Check return values for memory functions to handle allocation failures, and use tools like Valgrind to detect memory leaks and other memory-related issues. Let's consider an example of safe memory handling. The create_message function allocates memory for a message, checks for allocation failure, and uses the memory safely with snprintf. The caller is responsible for freeing the allocated memory to prevent leaks. By following these practices, you can write more robust and efficient C code. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.